Hello, everyone. My name is Terry Robinson, and I'm the Executive Editor for SC Media. Welcome to our webcast, Enhancing Threat Detections with Big Data and AI, sponsored by Databricks. Enterprises today face a daily barrage of cyber attacks. Responding quickly to threats is crucial to avoiding a serious breach. To do this successfully, security teams need to monitor and analyze billions of data signals each day. Yet existing security tools are struggling to keep up. Threats are going unnoticed and remediation timelines are being pushed out. Overcoming these challenges requires a new approach to threat detection rooted in data science. Our speakers today are David Myers, Senior Vice President Product, Databricks, and Barak Yavuz. He's the software engineer at Databricks. David leads Databricks product organization spanning product management, user experience, and documentation. He previously served as VP of Engineering and then VP of Product Management at OneLogin, a cloud identity and access management solution. Prior to that, he co-founded University Now, an accredited open university system running product engineering and UX. David has held leadership roles at SAP and Plumtree. Barak is a software engineer at Databricks working on structured streaming. His contributions have been used by Databricks customers to enhance their cybersecurity analytics. He's been contributing to Apache Spark since Spark 1.1 and is the maintainer of Spark packages. In the past, he served as a guest lecturer on Spark and machine learning at UC Berkeley, UCLA, and Istanbul Sayre University. They are well versed in this industry, and I would like to welcome them here today. Hi, David and Barak.
Hello. Hello. So thank you. Wow, that was quite an introduction. I am very excited to be here today. This brings together some of my heritage in identity and access management with the leading tool and system and platform for big data. So I couldn't be more excited to go through this material. We want to have a deep kind of conversation at the end with your questions. So throughout the presentation, anything that comes up in your mind, I'm sure someone else will have it too, please jot it down and we'll make sure to include it in the end. So today, threat prevention is increasingly complex, but why is it so complex? We've all known the tools that we've been using for, threat detection, the intrusion detection and response over the last couple decades, but they can no longer deal with the demands of the problem. One key aspect is our data collection volumes are just exploding. We have customers that ingest a petabyte a day of security events. Most companies, most enterprises are dealing with at least, 6 more terabytes per month. And not only is this ingestion rate increasing, it'll continue to increase exponentially as more and more entities start spitting out signals, and you have to correlate these. And we'll talk about some more of those trends in a moment. At the same time, the sophistication of cyber threats are astounding. The things people are able to do, jumping through bastion hosts, getting to maybe a cloud service and jumping onto your internal network is expounding with all the new surface area of your environment. It used to be you had perimeter-based security, everything was physically behind a firewall. Now you have networks, private clouds, public clouds, and there's so many more entry points that you have to be aware of. And lastly, the penalties are crushing. You can have, gigantic financial effects. It can have deep brand and trust effects. It can put you out of business. It can send you to jail. So there's this incredible problem. People are under-tooled to deal with it, and that's what we want to talk about today. So the existing solutions are critical. They provide critical value. But at the same time, with all these megatrends, they're too limited. So in a typical SIM, for example, you don't have all historic data. Because of the cost of the storage and the business model and some of the technology, you're typically looking at maybe a week, a 2-week, a 1-month window of data. and it's also built for weblogs historically, and more types of systems, and you can plug in to them through APIs, but they're not usually aggregating all of your systems. You might have key data in a structured database behind your application that you need to correlate with all of this event-based streams. And how do you do that in a SIM system? You have to invent a lot of data engineering to do that. So it can't integrate everything. And then it's based on, regular expression pattern matching. That's the same thing a lot of IDS is based on. So as you get to these kind of data volumes, pattern matching breaks down. You might have been in a situation where a few years ago you got 80 alerts a day, and your security team could validate that they weren't an issue fast and put them to bed and not, wake everyone up to chase it down. But now with this increasing data volume and all these events, if you're using pattern-based matching, you'll have 8,000 a day. And that's a totally different problem. What do you need to do to solve that problem is add machine learning and AI, and you need an analytics platform. Well, again, the SIMs and the IDSs and the snorts and things like that weren't built for that problem set. So you use AI machine learning to reduce the number of false positives, so you have enough you have enough signal, a small enough signal that you can react to, get the insights you need to react. And you don't have to have dozens of engineers building this for you, because modern unified analytic platforms basically do it all for you. So let's talk about threat analytics as it exists in most enterprises today, kind of the state of the art for the last decade. You have security infrastructure pulling in signals from DLPs, antiviruses, load balancers, and these weblog kind of things. You have all of your security policies in your cloud infrastructure and apps, and the audit logs from those often going to your SIM as well. You have to make sure all of your servers infrastructure is patched with zero-day security issues. Your network infrastructure is oftentimes the first line of defense, and strong authentication, multi-factors, etc., against the right identity providers. And then you can also tap into threat intelligence feeds from organizations that monitor bad actors in the greater web. So a lot of these things you pull into the SIM. Some other things aren't as easy to, and you might be just dumping them in a data lake. And then you typically have engineers do complex ETL to package these things into separate data warehousing infrastructure, some for incident response, some for alerting, because it has to be very fast kind of alerting on stuff coming in real time, and then reports, a separate warehouse to deal with the longitudinal information over the last few years. So you can look at trends and spot issues that way. And so this is a lot of infrastructure. And as a result, even with all this infrastructure, for the alerting, you're only really looking at a few weeks of data, and it's really expensive to scale, and it can't do the AI and ML that let you, reduce the signal to something manageable by your team. So with a unified analytics platform like Databricks, and then the new capability we announced at Spark Summit Dublin called Delta, we can do this all in a continuous pipeline that addresses all of the things we talked about before. So you can stream massive amounts of data. You can correct that data and augment it with machine learning or AI using the Spark runtime as it's coming in. And then once you have the data in the system, you have a collaborative workspace where response teams can work together to figure out the solution and solve the problem. We're going to be looking at all of this in a minute. I'll be handing it over to Barak now to talk about this first stage of bringing all the information together in a single, simple tool that is much easier to use than that gigantic mess you had to build with yesterday's technology.
All right, thank you, David. We can have So, welcome to the Databricks Unified Analytics Platform. We are currently viewing the landing page of the Databricks Collaborative Workspace. This workspace is where you can unify your data engineers, data scientists, and security analysts to collaborate on bringing value and security to your organization. So to perform any kind of analysis, we first need compute resources. Let's click on the clusters page. Here, with just a few clicks, we can launch clusters, fully managed clusters of massive scale, terabytes of RAM, and hundreds of CPUs within minutes. And all of this power allows you to run Apache Spark at scale with Databricks runtime. So in order to do my analysis, I already have a cluster set up. So now let's take a look at a notebook. So a notebook is an interface composed of cells that allow you to execute blocks of code independently. In this notebook, what I'm going to show you is how to unify information from multiple data sources, such as David mentioned, and which are available in many data formats. So you might have your audit logs from your cloud providers, such as AWS, like AWS CloudTrail. These log files could be in JSON. You could have rows set up on your network, which are sniffing on packets. These are provided in tab-separated format. You could have an application like Snort running, which is a network intrusion detection system, collecting logs, saving them out as binary. And you might have your SIEM, such as Splunk, which is keeping all your data in a database, which you can query with JDBC. So with Apache Spark and its wide ecosystem of connectors, we can collect all this data and then stream ingest all of it into Databricks Delta. And Databricks Delta will allow you to scale over all your data over all time, and also provide you the query performance of the business speeds that you need. And from Databricks Delta, you could additionally have streaming analytics, which are kind of the ML and AI intrusion detection systems that you can run, and also generate dashboards for your reporting purposes. So in this demo, we will stream log files residing on Amazon S3 into Databricks Delta using built-in functions in Apache Spark. And then we're going to set up some streaming jobs that alert us through PagerDuty when anomalous behavior is detected. So first of all, let's take a look at some of our log examples. So I have some connection logs here. As you can see, it's a text file, but it's separated by tabs. There are many columns, but I can't make sense of them at the moment. Similarly, we have FTP logs. Again, tab separated, there are like some binary data as part of the columns. And I can have SSH logs, which are simple, which are human readable, but not immediately queryable. So what I would like to do is turn all of this data into queryable tables. And before that, since these are structured logs, we already know the schema of these logs. They're well documented, and we will provide these for you. So defining all the schema for connections, HTTP, SSH, as well as CloudTrail, we can easily ETL all this data into Databricks Delta. So let's take a look at how our logs look like once we actually transform into nice tables. So now we have this nice table which has the timestamp column, UIDs, the originating host of the connection, and the responding host of the connection. Now this makes a lot more sense to me when I take a look at it.
Time is a little hard to understand, Barak.
Yeah, the time is a little hard to understand. I don't know what 133 is. And then there
birth date.
It's your yeah. And then there are like some things that we can improve here. Definitely improve. So one of the functions that I'm going to do, it's like the tunnel parents, empty means null to me. I want them to be null so that I can save on my storage and then make Spark querying much faster. So I'm going to write this very easy UDF, 6 lines of code in Python, and then combining it with UDFs already available in Spark, I'm going to make my table just a little bit nicer. So now we can see, okay, timestamps are actually 2012, they're human readable. My tunnel parents are null, which is great for Spark performance and storage costs, and dates I have nice dates.
So we have a massive set of data going all the way back to 2012.
Oh, yes.
That's awesome.
In addition, we're currently only with 22 lines of code. Very simply, we're logging all of these logs in streaming mode. And as you can see, we're reaching rates of about 2 million records per second, which is great.
That is.
And we're doing it all at very low latency, 5-6 second latency. Similarly, we have CloudTrail logs, which we can parse in only 25 lines of code. And this will provide you with insight into the events happening in your AWS account, which we will get later to in the second part of the demo. So if we look at our data size here of some of the connection logs that we've collected, you can see we've mentioned that we have data over years worth of records. You're going to see that we have petabytes of data, as you can see here, about 1 million gigabytes. This is a huge amount of data to handle. And with Databricks Delta, functions such as indexing, caching, you can actually make this data queryable and valuable to your company.
That is sweet. Let's go back to some slides and talk about what we can do with all of that data. Back to the slides, please. Okay, so I mean, those of you that are practitioners of security and response systems like this and are responsible for it, realize the size of a petabyte of data. The ability to bring that all in, have it coming in real time, and be able to query off it at business speed, but yet be able to decorate it with machine learning and AI and all these other things, as you're about to see, is pretty tremendous. What we've heard from our customers using this, it's not that this makes their lives a lot better from what it was. It allows them to do things that were impossible for them with the previous generation of tools. So the type of security monitoring and analytics and response that they can do is a new class of capability that without this they were incapable of doing at any cost or with any team or any tools. That's exciting for us. So this gives you complete visibility. You have the real time plus the years of historic data, a single view of all of it, no matter how many sources you bring in, and then you can start to do the magic. You can start to take this ridiculous amount of data and events and winnow it down into actionable signals. And the way you can do that is with ML and AI and any other analytical tools you need. For example, some of your team might be used to looking at this data with SQL. We now have these nice tables and good structure, and you can use comparative date structure because of the date-time format, etc. Other people on your team might be used to Python for data science or Java for some other things from apps. You can use all of that on this platform across this breadth of data. It's fully managed in the cloud. You can get this rolling in a very short period of time. We have auto-scaling clusters. You saw when he was running jobs on massive data, he didn't have to think about how to build systems for that. It was just there, and it just worked. And then with auto-scaling resources, you only pay for what you need. You don't have to have a massive cluster waiting there for when you might have an incident that's, once in a blue moon. It just is instantly at your fingertips when you need it. So in more detail, let's talk about some threat detection use cases. So there's a notion of advanced pattern matching or user and entity behavior analytics. People used to refer to it as user behavior analytics, but a lot of the signals no longer coming from humans. They're coming from other entities that human might compromise. So they might be individual machines, phones, network appliances, and things like that. So bringing all of these together, you can start to identify patterns in user behavior and find anomalous activities. But it's basically a pattern matching approach. So to really do the next level of analytics and be able to deal with all of this data, you need to use ML. So let's talk about how that could work. So in every event, there's actors and there's basically nouns and verbs describing what happened. This IP address accessed this resource at this time with this agent header, for example. So what you can do is build all of those into a model which can score individual events, but you train the model over a long history. So you start to see when the actor David Meyer is doing things, maybe he has a new agent header on an OS he doesn't normally use, or he's coming in from a place that had impossible geovelocity. You can do all of this if you look at long-term things and correlate them with the specific event coming in. And you need the long duration, but you also need the analytical capability against the stuff just coming in now, because you need to score the event and respond to it as soon as possible before the damage is done. Okay, so you find an event. What next? You have to do your impact analysis. Now, imagine the world when you have 2 weeks of data, you see an event happens, and you see that they were only really in the system today, and they weren't in the system the previous 13 days. Whew! That's good. I know they didn't access anything compromising. That's usually not the whole story. Usually they were in a month ago, 2 months ago, kind of probing the boundaries of the network, maybe extracting some identities to deploy later when they knew enough of the system that they could get something valuable before they were detected. So the 2-week window basically tells you a myth of what you want to believe happened rather than what actually happened, and later on you're likely to be surprised. So the complete history, the full set of analytical tools, collaborative in nature to address this, is what is needed in today's modern environments. So I think let's look at what some of that might look like, Brock.
All right. Thank you, David. So right now, looking at is a Databricks job. So Databricks jobs are where you run your production applications. Production applications require a host of services to keep them up and running. And Databricks jobs allows you to schedule your batch applications. They alert you in case of failures, and also, in fact, in case of failures, they can retry. In distributed systems, failures are common and expected, and it's very important to be able to know when to look at a failure and when you know if it's a legitimate failure or just a transient failure. And as well as retrying, you can take a look at the history of all your running applications. So what I have deployed as a production application here is an intrusion detection stream. So what I'm looking at my CloudTrail logs. And what I'm doing is I'm windowing it by time, so windowing it by every 10, 15 minutes, and putting a delay of 15 minutes as well. And I'm running this detect anomalous behavior function, which could be composed of the ML and AI applications that David mentioned, where you're looking at the event orders and such. And what we're doing is we're taking a look at how risky are these events. So this function's giving us a risk factor where, there could be noise, so we're filtering out 60% of the events. And then we're writing them out into Databricks Delta again. And what we're doing after that is we're reading it back. And what we're doing is we're writing these, alerts out into PagerDuty to give me any, alerts if something goes wrong.
Your phone's going off.
Oh, man. That's embarrassing. Sorry. Let me look at this. Oh. This got paged by PagerDuty. Let's take a look.
You're saying for real?
Yeah, this is for real. Have this dashboard, security dashboard, and there's like a latest alert of 72%. what just happened.
That's out of 1, right?
Yeah, and it's in UTC, so 19 o'clock, it's 8 hours, and Pacific time, it's 11:25 here. This is just very new. And you can see, like we're tracking all this stuff of where these actions are coming, but, this dashboard itself doesn't give me much. Let me go into a notebook and do some very quick ad hoc analysis. So I've received an alert from PagerDuty. I've looked at my dashboard and I figured out which AWS account has this weird behavior. Let's take a look at what's going on.
Oh, thanks for inviting me to that notebook. I'll go in it too.
All right. So using Delta's indexing functionalities, I'm just going to look at today's data because that's when I received the alert. And this is going to make my querying much, much faster. So let's take a look at where the account is being accessed from. I've filtered out our company VPN. Oh, I've got like one IP which has orders of magnitude more counts. And then there's all these like 35 dot something IPs doing stuff. Since this is like pretty distributed, let me take a look at the 35s first. So who owns all these 35 IPs? Seems it's Amazon. Okay, that's expected. Events are happening within Amazon's account. What are they doing? So describe instances, describe stream. They're probably running a Kinesis application. This was boring.
Yeah, that's pretty harmless.
Yeah, that's harmless. Who's this 81 guy? Amsterdam? Hey, David, do you know anything about...
our team there, but this is not... Oh, scroll up a second. Oh, whoa. Yeah, this does not look good.
Yeah. Let's take a look at who this guy is. Oh, it looks like a VPN. That's... Okay. Should look into this. Let's look at which account IDs they've used from this IP address. Okay, so they've used this access key ID in Amazon from this IP. So let's take a look at all the events that they've did with this access key ID. There's like this group of get login profiles. I think they've tried to, like list all the users that have access to our account. So it's interesting, but
that's disturbing.
That's disturbing. Let me just filter out some of the read-only events with a UDF such that I can get a sense of what they did that could be harmful. Oh, put user policy and a create login profile. Seems like they've created a new account for themselves. So
what are they doing with it?
So now we need to look at their ARNs because when you're looking from the web console, you don't use access keys anymore. Okay, so we have 2 users that have this IP address that have looked at our AWS console. Let's take a look at account 1. And David, can you look at account 2, please?
Yeah, looking right now.
So the account 1, that's how they created the login profiles. Account 2, request spot fleet.
They're spinning up new stuff.
They're spinning up new stuff. Let's take a look at what they're spinning up.
Whoa.
Okay, there's like hundreds of instances with and what kind of instances are they? They're like very large, beefy GPU instances.
Oh, they're doing something bad. They're probably like coining or something.
They're probably, Bitcoin's at 9,000 or 10,000. There might be coining. And like,
well, we got to get this out of the system right away.
Yeah.
Can you alert the rest of the team to shut them down?
Yeah, sure. Let me just collect their request IDs. And now we can rotate the credentials for the compromised accounts and then turn off all these spot fleet requests.
Awesome.
Because some are costing us $6,000 an hour.
So let me ask you a couple of questions. We figured that out really fast. Obviously, you had some code ready there, and so that probably would have taken, maybe an hour, not 10 minutes, to do it in reality. And then, sometimes you naturally just flowed into doing SQL, and sometimes you had some Python going on. So that seems critical for a situation like this.
I use what I'm most comfortable with, and that's very important.
And then anyone you invite into the notebook can use whatever languages they're familiar with.
Exactly, and coding together here is critical.
And then
debugging this very quickly.
And then it looks like, once we have to write this up with an RCA and maybe talk to the government about what happened, we have a full history, audit trail of everything we discovered and when for the report we have to write up compliance-wise later.
Exactly.
Dude, that's awesome. Well, let's go back to the slides. So that's the main gist of the webinar, to talk about these new class and scale of problems people encounter as their technology topology changes to include a lot of different, public cloud, private cloud, etc. The application portfolio their employees are using are spread everywhere. And then the attacks are getting much more sophisticated, and the data volume their security team has to deal with is mind-blowing and will be doubly mind-blowing in a couple months. So we're very excited about taking a new class of tool and technology to solve this problem, the leading platform for big data analysis, which is Spark, in a fully managed environment. That was really great. Thank you so much, Barak, and let's pass it over to questions.
Okay, great. Thank you for your input, Barak. Interesting presentation. Now we're going to open it up to questions from the audience. Let's see. Okay. I already have SIM. How would this be used as a replacement or in conjunction with it?
Yeah, so, a SIM is a foundational piece of your security infrastructure. Databricks is not a SIM. But it's an and. So basically, the SIM provides this high tooling and all your capabilities, oftentimes on a restricted window of data. And what you do is you also, as this data is coming in, bring it into an analytics platform like Databricks, and then you can do all the longitudinal analysis and massive volumes. Now, another key differentiator is, we're letting you store all your data in open source formats, Parquet files, for example, in your Amazon S3 account or your blob storage in Azure. And that's very inexpensive storage compared to a lot of the storage systems in typical SIMs. So it's a very inexpensive way where you can afford to have all of your data over all time to do this analysis as an adjunct to your SIM system.
Okay. Since this is all hosted in the cloud, how can you ensure that my data is secure?
Well, this is a fascinating question. It's a fascinating topic. There's a lot of different lenses to look at that with. The type of analysis we're talking about to scale these out in an auto-scaling fashion on any data load for any analysis you need to do is incredibly difficult to replicate on-premise. And the key security benefit here is you have access to all the data in real time. Now, we work with customers with the most stringent compliance needs, whether, federal, HIPAA, et cetera, where they have to have regulations, where they have to keep data in certain ways. And we are leading in certifications in the big data world. And a lot of security experts will tell you it's very hard to maintain the level of security and protection in an on-premise environment. And it's a lot easier to do it in the cloud where experts, topmost experts in the field, are verifying this stuff continuously. So if you have some of the brightest people in big data security and intrusion prevention that work for you on your staff, and you have the capability to auto-scale things, you might be able to achieve the same level of security that Databricks natively has with none of your intervention in the cloud. But it's security is a core tenet of our vision, our philosophy, and our operational style, and we have the certifications to prove it.
Okay. Well, how is Databricks priced then? My current SIM licensing model is based on per gigabytes of data indexed. How does that compare?
Yeah, so the Databricks is a platform. It engages your Amazon or your Azure account where a lot of the data is stored, again, in inexpensive storage, be it Blob Store or S3. And Databricks does not charge you for your storage. Databricks charges you for the work you do on your storage. So you can bring all of the data in, just paying this very commodity cost of storage. And then it's the response that we empower you to do by scaling out these clusters, which is what you pay Databricks for. And it's very cost effective, much less expensive than doing it with historic tools that you might have at your disposal.
Okay, and where's it available?
So Databricks is available for anyone that can sign up for an account today after this and start playing with it. Some of the Delta capability we talked about is in a technology preview program that you have to apply for, but it's being rolled out to more and more customers, and it'll be fully available in the first half of next year. We're available in AWS and in Azure, and you never know what additional clouds will be added over time.
Okay, and are there any data limits? So, like, what's your biggest customer deployment?
So right now, it's at around targeted for a petabyte of ingest a day, but that's not near a theoretical limit. The nature of what Spark can offer in at-scale, in-memory compute, scaled across gigantic clusters that auto-scale, we look forward to the size that would make us sweat, but we haven't seen it yet.
Okay, well, that's going to have to be it for this session. Just a reminder that this webcast is going to be available on demand beginning tomorrow on scmagazine.com in our events section. I want to thank you all for being with us today, especially you, David and Brock, and tune in to see what's up next.
Thank you so much.
All right, thank you.